Installing a motor control center in front of an existing window in an industrial application may raise some code concerns. The National Electrical Code Section 430.24 mandates that motors must be safeguarded against overheating stemming from ambient temperature. Positioning the motor control center directly in front of a window could expose it to direct sunlight. This exposure elevates the risk of motors overheating. The National Electrical Code Section 430.24b stipulates that motors should be shielded from the adverse effects of moisture. Installing the motor control center near a window can potentially expose it to rain or snow, leading to motor damage. Then there's National Electrical Code Section 430.24c, which demands that motors are protected against the detrimental effects of dust and dirt. A motor control center placed in front of a window might be vulnerable to dust and dirt accumulation. Such accumulation could obstruct the motors and ultimately lead to their failure. Firstly, assess the potential for direct sunlight exposure through the window. If the motor control center will be consistently exposed to direct sunlight, consider relocating it or implementing shading solutions. Overheating can significantly reduce the lifespan and reliability of motors. Secondly, evaluate the potential for moisture ingress. Windows, especially those in older buildings, can be prone to leaks. Ensure that the motor control center is adequately protected from rain, snow, or condensation. Moisture can cause corrosion and short circuits, posing safety hazards. Thirdly, analyze the level of dust and dirt present in the industrial environment. If the area is particularly dusty, consider using a sealed enclosure for the motor control center. Dust and dirt can clog motor vents and impede cooling, leading to overheating and premature failure. Apart from the National Electrical Code prerequisites, other local codes or ordinances might govern the installation of motor control centers. Checking with local authorities is crucial to determine any specific requirements that must be met. They may have additional guidelines regarding placement, ventilation, or environmental protection. When planning to install a motor control center near a window, prioritizing motor protection from the elements is paramount. This could involve installing a weatherproof enclosure, which provides a physical barrier against moisture, dust, and sunlight. Ensure the enclosure is appropriately rated for the environmental conditions. Another method could be utilizing other strategies to shield the motors from moisture, dust, and dirt. Consider installing a ventilation system that filters the air entering the motor control center, reducing the amount of dust and dirt that can accumulate. Additionally, regular maintenance and cleaning can help prevent the buildup of contaminants. Proper planning and adherence to codes are essential for ensuring the safe and reliable operation of the motor control center. Failure to address these issues could result in equipment damage, safety hazards, and code violations. Consider consulting with a qualified electrical engineer to assess the specific site conditions and develop a compliant installation plan. The engineer can evaluate the potential risks and recommend appropriate mitigation measures. When dealing with electrical installations, always prioritize safety. Ensure that all work is performed by qualified personnel and in accordance with applicable codes and standards. Neglecting safety precautions can have serious consequences. Proper selection of the motor control center enclosure is critical. The enclosure should be rated for the environmental conditions present at the installation location. Ingress protection ratings such as I65 or I66 indicate the level of protection against dust and moisture. The enclosure material should also be suitable for the environment. For example, stainless steel enclosures are often used in corrosive environments. Furthermore, consider the temperature rating of the enclosure. The enclosure should be able to withstand the maximum and minimum temperatures expected at the installation location. Overheating of the enclosure can damage the internal components. Proper ventilation is also important for maintaining the temperature inside the motor control center enclosure. Adequate ventilation helps dissipate heat generated by the motors and other components. Ensure that the ventilation openings are not blocked by obstructions. Consider using forced ventilation, such as fans, to improve airflow. Regularly inspect the ventilation system to ensure that it is functioning properly. The placement of the motor control center should also consider accessibility for maintenance and repairs. Ensure that there is sufficient space around the motor control center for technicians to safely work. Provide adequate lighting in the area to facilitate maintenance activities. Consider the ergonomic aspects of the installation to minimize strain on technicians. Regular maintenance is essential for ensuring the long-term reliability of the motor control center. Develop a maintenance schedule that includes regular inspections, cleaning, and testing. Train personnel on proper maintenance procedures. Keep detailed records of all maintenance activities. Address any issues promptly to prevent them from escalating. The National Electrical Code provides comprehensive guidance on the installation and maintenance of motor control centers. Familiarize yourself with the relevant sections of the code and ensure that all installations comply with these requirements. The National Electrical Code is updated regularly, so stay current with the latest revisions. Consider attending training courses on the National Electrical Code to enhance your knowledge. Local codes and ordinances may impose additional requirements beyond those specified in the National Electrical Code. Contact the local authorities to determine if there are any specific requirements that must be met. Local codes may address issues such as seismic requirements, environmental regulations, and fire safety. Comply with all applicable local codes and ordinances. Consider the potential for electromagnetic interference, also known as EMI. Motor control centers can generate electromagnetic fields that can interfere with other electronic equipment. Minimize electromagnetic interference by using shielded cables, grounding the motor control center properly, and separating sensitive equipment. Conduct electromagnetic interference testing to verify compliance. The selection of motor protection devices is crucial for ensuring the safe and reliable operation of the motors. Select motor protection devices that are appropriately sized for the motors being protected. Consider factors such as motor full load amps, starting current, and service factor. Use overload relays, short circuit protection devices, and ground fault protection devices. Regularly test the motor protection devices to ensure that they are functioning properly. Grounding is essential for electrical safety. Properly ground the motor control center to provide a path for fault current to flow back to the source. Use a grounding electrode system that complies with the National Electrical Code. Bond all metallic parts of the motor control center together. Regularly inspect the grounding system to ensure that it is intact. Surge protection is important for protecting sensitive electronic equipment from voltage surges. Install surge protective devices at the motor control center to protect against lightning strikes and other voltage surges. Select surge protective devices that are appropriately rated for the application. Regularly test the surge protective devices to ensure that they are functioning properly. Proper labeling is essential for safety and identification. Label all components of the motor control center clearly and accurately. Use durable labels that are resistant to fading and abrasion. Label all disconnect switches, circuit breakers, and other control devices. Provide warning labels to alert personnel to potential hazards. Training is essential for ensuring that personnel are qualified to operate and maintain the motor control center. Provide comprehensive training on the operation, maintenance, and troubleshooting of the motor control center. Ensure that personnel are familiar with the National Electrical Code and other applicable codes and standards. Regularly review and update the training program. Documentation is essential for tracking the installation, maintenance, and modifications of the motor control center. Maintain accurate and complete documentation, including drawings, specifications, and maintenance records. Store the documentation in a safe and accessible location. Regularly review and update the documentation. Risk assessment is an important part of ensuring the safety of the installation. Conduct a risk assessment to identify potential hazards and develop mitigation measures. Consider factors such as electrical shock, arc flash, and equipment failure. Implement safety procedures to minimize the risks. Emergency preparedness is essential for responding to unexpected events. Develop an emergency preparedness plan that outlines the steps to be taken in the event of an emergency. Train personnel on the emergency preparedness plan. Regularly review and update the emergency preparedness plan. Consider the potential for energy efficiency. Implement energy-efficient measures to reduce energy consumption. Use energy-efficient motors, variable frequency drives, and other energy-saving technologies. Regularly monitor energy consumption to identify opportunities for improvement. Consider the potential for harmonics. Motor control centers can generate harmonics that can distort the electrical waveform. Mitigate harmonics by using harmonic filters, reactors, and other harmonic mitigation techniques. Conduct harmonic analysis to verify compliance. Consider the potential for cybersecurity. Motor control centers are increasingly being connected to networks, making them vulnerable to cyber attacks. Implement cybersecurity measures to protect the motor control center from unauthorized access. Use firewalls, intrusion detection systems, and other cybersecurity tools. Regularly update the security software. Consider the potential for remote monitoring and control. Remote monitoring and control can improve efficiency and reduce downtime. Implement remote monitoring and control systems that allow authorized personnel to access the motor control center remotely. Use secure communication protocols to protect against unauthorized access. Consider the potential for predictive maintenance. Predictive maintenance can help prevent equipment failures and reduce downtime. Implement predictive maintenance techniques such as vibration analysis, infrared thermography, and oil analysis. Use data analytics to identify potential problems before they occur. Remember to account for the specific environmental factors and potential hazards associated with the industrial setting. Consulting with a qualified electrical engineer and adhering to local codes are essential steps to ensure a safe and compliant installation.